Hi, boys and girls. So I have a few shout outs today. First of all, shout out to everyone for being so good while I was gone and for your cooperation. Thank you. I appreciate you. Shout out to all of my tutoring peeps who came and are working hard. Thank you. And shout out to Justin who helped to teach and help everyone while I was gone in his class. I appreciate that as well. All right, so we're on our next unit, which is actually really our last unit. And we're going to start to talk about surface area. Now, I think you talked about surface area last year, I hope. So let's see what we remember. When we're finding the surface area of a figure, it's the area, so surface area, is the area of all faces of a 3D figure added together. Okay, and that's for total surface area. So if you were to take this box here, this rectangular prism, and cut it open, this is what we would have. We would have this, it's called a net or a flat pattern. Here was the bottom, and then it unfolds. You had the two ends here. You had the front, the back, the top. If you were to say, like, how much cardboard did we need to make this box? If you found the area of each of the rectangles, and there's 1, 2, 3, 4, 5, 6 rectangles, added them all together to give you the total surface area. So how much cardboard is on the surface of that box? There are two types of surface area. There's total, which is basically what it says. It's all faces added together. And then there's something called lateral surface area. Okay, so it's the faces, so I should say area over here. Area of all faces. Area of faces except top and bottom, which we are going to call the bases. Because remember, the top and the bottom are the exact same thing. So if you were to turn it over, the base would be the same, whether it was on its top or whether it was on its bottom. Okay, so that's total surface area is basically what it says. It's the area of every single face added together. And lateral surface area is the area of the faces except for the top and the bottom, which are our bases, added together. So lateral is like talking about like the label on a soup can. So if you can picture a soup can, okay, watch my can here. Isn't this a nice can? So think the label just goes on this part here. Does it go on the circle on the top? It doesn't go on the circle on the bottom. It just goes around the middle. That's lateral surface area. All right, let's practice. So to find this total surface area, we're just going to do total surface area right now. You find the area of each of the faces and add them together. So let's just work on these nets here. So this is what I think you did last year. So this first rectangle here, the first rectangle is 3 by 9. So 3 times 9 is 27. Okay. This rectangle here is 4 by 3. 4 times 3 is 12. This one over here is also 12. Okay. There's going to be 2 of each face for a rectangular prism. So each face repeats once. Or repeats twice, I guess, however you're going to think about that. All right, let's go underneath the 27. That's 9 by 4. This right here is 4. 9 times 4 is 36. Underneath of that is 9 times 3 again, which is 27. And then underneath that is 9 times 4, which is 36. Remember, area of the rectangle is equal to length times width. So over here we did 9 times 3, 9 times 4, 9 times 3, and 9 times 4, and these were both 4 times 3. Now we add all of the areas together. So we had 27 plus 36 plus 27 plus 36 plus 12 plus 12. So 27 plus 36 plus 27 plus 36 plus 12 plus 12. and we get 150 centimeters squared. Surface area always has units squared. We talked about that today. Okay, let's look at another one. What we're going to start to do tomorrow is we're going to talk about a formula, because you're not usually going to see it unfolded like this. Usually the box is going to look like this. The hardest part of this is identifying the base. That's why we kind of practice with that in class today. So we want to find the area of all of the faces here. Okay, so this face here is 3 times 6, which is 18. Okay, this one here, this is 2 going this way and 6 going down this way. So 2 times 6 is 12. This is 2. And this here, so going this way is 3. So this is 2 times 3, which is 6. Okay, this is 18 again. This is 12 again. And this is 6 again. Remember, each base repeats. So then we add them up. 6 plus 6 plus 12 plus 18 plus 12 plus 18. And we get 72 centimeters squared. Okay. How's this shape different? Well, it's got triangles for the base. So if we see here, there's a triangle for the base. So we're going to find the area of each base. So this first one here, we'll start over here. This is 3 times 4, which equals 12. And this is a triangular prism. Okay, their faces don't always repeat. All right, so then in the middle here, this is 3 by 3. It's a little square, so that gives us an area of 9. And then this here is 5 by 3. So 5 times 3 equals 15. Now we have the triangle. Remember, area of a triangle is 1/2 base times height, or base times height divided by 2. So this is going to be 4 times 3 divided by 2. So 4 times 3 is 12, divided by 2 is 6. And this is going to be this this triangle up here is the same exact triangle. Okay, this is a 4 by 3. So this is also going to have an area of 6. So now we go ahead and add all of the areas together. So 6 plus 12 plus 9 plus 15 plus 6. And that gives us an area of 48 centimeters squared. All right, you ready to try 2 on your own and bring them in tomorrow? First one, what's special about this one? This is a cube. So see if you can find out here. Remember, the thing that's special about a cube is all of the 6 faces are exactly the same. So basically, the area of each of these 6 faces is going to be the same. Okay? And then try this one. The net shown below forms a rectangular prism. Find the surface area. Okay, I'm going to give you a little hint here. I'm going to help you with this is 5, this is 5, and then these are all 2 here. Okay, and this is 5, this is 2. All right, let's try those, write them down, bring them in tomorrow, and have a good night.